Let's do this. Okay. Live from Waukee High School. Check this out. So on the big screen, I'm going to go full screen here. Let's do it. Full screen so you don't have to see all that other stuff. Enter full screen. Logistics. So let's play with this rumor model just real fast. And the only reason I bring this up is we're going to have our calculator here in a second. And we're going to graph this crazy model, this 1300 over 1 plus 39. Yeah, that thing. And you guys are going to use your calculators, and you're going to help me out. I'm going to depend on you, totally digitally. And do you guys know what page this is? It's right before 3.3 in your note packet. Okay. So I'm going to zoom in on that thing. This is the big key is when you see a logistic function, it always has this form. And remember lice minus lict? There's the L, there's the I, there's the C, E to the LKT. It's awesome. It's all in there. But that's the lice minus lict. That's the form of your logistic model. And the top is your upper bound. It has a cap. Like if you're spreading a rumor, you can't spread it to more people than there are in the school. So there's always that upper limit. And when you graph it, it's a quick sketch of just those things. And you want to, the things that we had you graph in that quiz, that's why I brought that quiz out first, those are the key components of a logistic. Now, I drew this poorly. I mean, so poorly I'm going to redo it. Got to do it again. Cannot have such a graph. So I'm going to go logistic, like that. And then across the top, y'all know we got this horizontal asymptote of 13 hundo at the top. That's where it caps off. And there's this, do you remember anything about like the moment of greatest rate of increase? Like when it's speeding up, the rumor is really spreading. It's going nuts. Remember that part? Remember right there in the middle there? Speeding up the fastest at 750 or whatever that is, something like that. Oh no, 650. That's when the rumor really takes off. But the other part, that's interesting, but more interesting than that is we would like to know where that y-intercept is, and you guys remember that comes from putting in 0 in for x in our original function. And so if I put in 0, or for t in this case, if I put in s of 0, this will give us our y-intercept and help us finish that graph a little more accurately. So 1300 over 1 plus 39e, and you put in 0, and for that, and it's just 0. Anything times 0. And that makes it 1. E to the 0 is 1. So it's 1300 over 40. And y'all got the calculators on there. What is 1300 over 40? What's that make? And say it really, you gotta say it fast, and I'll borrow it, and you'll be recorded. You can be famous. There it is. Eric wins. What'd you get, Eric?
32.5.
32.5. Ladies and gentlemen, this is Eric. What a guy. So 32.5 roughly right in there. That's where it crosses. So, hey, that gives us an image of what this looks like. That's actually where it starts. It starts with 32.5 students knowing this rumor. Sounds like a really full class. And the 32.5 is that somebody kind of heard it through Twitter from the class, but didn't really understand what it was about because they weren't in the class. So there's 33 students in the class, and the half person is the one who was absent and heard it just on Twitter and got confused. Okay. Think that's true? That's how I look at it anyway. So how many students have heard the rumor by the end of day 0? Why, we just figured that out. That's 32.5. What we got is where we started. Day 0 is just this class. Bob, Carol, Ted, Alice, they start a rumor. The class, they're the ones they started in the class. Half a student heard the other part of it. Now, how long does it take for 1,000 students to hear this rumor? There's a way to solve for it algebraically, but I'm most concerned with your ability to utilize the calculator. So what we're going to do is you're going to go to y1, and you're going to type this in here. 13 hundo divided by, in parentheses, you're really, really, really carefully using parentheses, 39 e to the negative 0.9. I can do this. 0.9 e. And you got to use x, of course. So that goes into y1. And then in y2, you're going to put in 1,000. And this is the challenge to you. You've got to find where that 1,000 hits on your graph up above. So I'm going to go in with a nice pink line. You know it's up here somewhere. So 1,000 is up here somewhere. You got to graph it so you get a window that works. And then we got to find that intersection point where they cross. Okay, and that's your challenge at this moment. You can handle that one. Okay, so you're going graphing on me. You're graphing, looking for that. Graphing, graphing, graphing. Got this one? You find it? Clicking. I'm hearing clicking, kind of, maybe. Background, clicking. Click, click. Got that? Uh-huh. That one? All right, well, you do that. I'm going to use my super duper calculator. See if it comes up on your screen. We'll see. Come on, computer. New. I haven't used this in a while, so see if I can pull it off. So here it is, 1,300 divided by, you keep going and tell me if this is right, 1, what was it again? Is it 100? Dang it, I can't see my screen. 1 plus 39, got it. Oops, come back. No, come back. No. No. Yeah. I'm ready, and I'm going to find my favorite person to bother. Let's go with because you have a calculator in your hand, I'll bother you. Lacey, of course. Good grief. God, I thought I was going to call Nabon, didn't you? You were close. Okay, there's my graph. Lacey, did you get a graph going on this one by any chance? Whoa. So here's my graph. Whoa. I'm just squishing it until it hit. Oh, there we go. Finally got it to work. There's my graph. So I got this cool window where I can squish it and make it work. And I need to find the intersection, so let's add another, let's put one in there. Come on, graphy poo. Did I not do that right? Oh, no. Thank you. Is it negative not 0.09? It's just negative 0.9? Is that what you're trying to say? Okay. Ooh, look at that. It messed with the straightness of it. That's crazy. I think I can get that better. The window, axis, end values. I don't remember how to do this stuff. You don't use a tool very often. You get kind of mixed up. Window, quadrant 1, wedding settings, window, zoom, 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 zoom. Some fit? Maybe? Well. Yeah, I just want to be able to see that intersection. So I'm going to do this. I can do this. Okay. All right, Lacey, what do you have? Anything good? Yeah. What do you have for a number? I have 5.41. Okay. I wonder if I can get a intersection there. Can I get that? Ooh, now they're both flashing. Okay, 5.41. We'll come back to mine, see if I can make that work. 5.41. Got it. And what else? That'd be 1,000, right? So that tells me 5.41 is your intersection on there. That's where it crisscrosses. Now if I can graph that on my calculator, we'd be in good shape. I'm going to just type it as a point. Can I do that? No. Oh, I can do this. Wait, cancel? I bet it'll tell me. Uh-huh. Use actions grace. Ooh, trace? Graph, no. I've used this twice. Graph, entry view, actions. Analyze. Intersection. I want an intersection. Right there. Give me that one. Yep, 5. Hey, I did it. Making this up as I go. I'm getting there. 5.41. I agree. Yeah, nice work. That looks pretty good. So what is that, days? 5 days to get the rumor to 1,000 students? This is a student population that obviously doesn't have technology. Good grief. We get to 1,000 students in, what, a couple hours around here? You have a decent rumor? Like my extra toe? That rumor got around really fast last year. Crazy how quick that went. Okay, so now we're down to the bottom. That's the idea of that logistic. I want you to know the basics of the graph, and you have to be able to find the intersection. Now, are you guys familiar with how to find intersect on here? You graph them, second trace. You need to know that. If not, you want to come find me for special conference time on how to find intersections on your calculator. Super important. Down below,